All right.
1 second. I need to go through my privacy settings.
How's the project going, Bailey?
It's slowly coming along. We're still trying to figure out if we want to focus on our initial IP or if we want to switch it up just based on commercialization and everything. But we're getting there.
Yeah. The I read something about like the deadline getting extended to the 31st. Does that affect y'all's project too, or
No, it does not.
because I was looking at like different challenges and stuff, and one of them got extended.
Ours is due on February 7th, so that may be a different one. I know that for the different academies, they extended enrollment dates.
So the whole project's due on February, or
Yeah. And then based on that, they'll have selection and then we get to figure out who's going to pitch their IP.
it's exciting.
What's up, Donald?
Yeah.
Oh, damn.
Hey,
What? What? I can't say that. Okay. Is this?
Hey, can you guys see it?
we can see it.
Okay. So I guess the main things that I wanted to talk about, I feel like were, I guess, different in everyone's designs was the mounting of the altimeter and the, I guess, location of the parachute and stuff. So starting off with the chute. So what I wanted to do is keep a lot of that mass near the nose cone to help out with the stability. So I wanted to keep the center of gravity really, I guess, close to the nose cone with the parachute. And so I was thinking we could just use some type of centering ring or something of these sorts to hold that in place while still allowing the ejection charge to, I guess, transfer enough force and to adequately get to the nose cone and push it off. But that's what I wanted to kind of get some thoughts off of you guys, because obviously, I guess, I don't know exactly how much force will be applied through the ejection charge, and if I should be afraid of the force possibly like tearing the centering ring off, or maybe the force wouldn't be strong enough going through a hole in that centering ring and like be enough to push off that nose cone.
I think as long as there's a hole, the pressure is enough force, right? No matter the distance.
Yeah. So that's an interesting idea because, I mean, a nozzle is essentially a constriction in a flow, right? And so you're like just constricting it down so you get like pressure buildup. But I'm not sure exactly if like the black powder like exploding from the top of the motor, like the whoosh that comes out of it would cause the centering ring to push away.
Yeah.
I'm not exactly sure how much it has to constrict the flow before like you start feeling like a whole lot of pressure buildup. But I would say in your case, if your diameter is 3 inches, so what is that, like a 2-inch diameter hole, or like an 1.5 inch diameter hole?
Yeah, it's not anything set in stone right now. You know, I just kind of I just did it by sight, but yeah, it would be around 2 inches-ish, I believe.
I mean, I wouldn't see why that would cause a whole lot of problems.
Okay. But yeah.
Yeah. I mean, yeah, you guys can look at my L2 later, my design. It has something very similar. So I mean, we could probably like prove it somehow, but off the top of my head, don't think that should be an issue.
Okay. And yeah, I know I was talking to you about this like maybe a week ago, and you were saying the other option is to just kind of leave it in there and like just have it do its thing. And I'm guessing what I got from that is that you would say it would be like, I guess like down here, it would be sitting down here, and then the ejection charge would push it all the way back up to the nose cone, and then that would like have the force to actually take off the nose cone. Is that what you were saying?
Yeah. So
Yeah,
the
so
way the nose cone comes off is not necessarily by like the whoosh of like the black powder like exploding. It's like since it's exploding, it's increasing
Mhm.
the pressure inside of the rocket.
yes,
So
yeah.
before the nose cone starts like sorry, the parachute starts like spilling out, the pressure inside the rocket increases. And so
Okay, so you're saying the nose cone would come off before the parachute even reaches the top.
yeah.
Okay. And so yeah, the reason why I wanted to do the centering is because obviously if the chute was down here, just with the mass that I've given it in this file, the stability would be a lot less. So that was my reasoning.
Yeah. You can also get away with like getting your stability up to 1.6-ish again by just changing the size. You can make it 1/4 inch longer on each fin and
Okay.
call it a day.
Yeah. And then the other thing, I guess important thing that I wanted to bring up was the mounting of the altimeter. So the first and I guess best situation I was thinking of is to just putting something like a bulkhead up here and attaching it straight to that. But the issues kind of arose with how you would attach that bulkhead to the nose cone. So I was thinking something along the lines of having this bulkhead be maybe a 1/2 inch thick, and then having some screws coming in from the outside edge of the airframe, or something along the lines of that, because I feel like we should have some maintenance ability to that, being able to remove it and change things as needed. So I didn't really want to do epoxy or any more permanent solution like that.
That's great.
Yeah. I actually really like that idea. And just to brainstorm off of that, you could even have like a centering ring almost just like epoxy there. And then the altimeter or whatever is like on the little tray that it's on. And then the tray screws into the centering ring. If that makes sense. So like you have like this, I don't know. We'll go over it a different time. But I think that's
Okay. Yeah, because I had a few ideas like that with having part of it like permanent and like stationary in relation to the airframe and stuff, and then just having it like rotate or lock in place somehow. But I just thought that was a little bit too complex for this type of system. But other than that, I feel like everything else is relatively simple. I mean, with the fins, I just went ahead and did fin tabs going the entire length along the root cord, going down to the motor tube. And then I did take your suggestion, Gus, with the bottom centering ring going to the outer diameter of the airframe, just to kind of act like a retainer in a way. But yeah,
Nice.
Yeah.
any discussion or questions?
This design is meant to be an L2 after the L1, right?
Yes.
Okay. Cool.
Yeah, so that's where I guess the size of the motor tube actually comes into play.
You have a L2 motor in sight that you'd like to use?
Not a specific motor. I know you gave me a suggestion, and I believe it was the J motor. I haven't done too much research and looking into the different motors that I could use, but yeah.
He'll deal with that later.
Yeah, I'll deal with that later.
Yeah. I will throw out there, if you like are seriously considering an L2 after your L1 with the same like airframe and all that stuff, if you are gluing your motor tube inside and like the fins to it and everything, if you want to put that J270 in there again for a second.
Sure.
You notice how your stability is now at 0.9?
Yeah.
So if you wanted to launch again with like the exact same setup, your rocket would be doing cartwheels.
Yeah.
So
So we
Uh,
would have to change,
play around with
yeah, with fin size and just
it. Yeah.
location of mass and stuff.
Awesome. Thank you.
Okay.
Does anybody else want to share their designs? I think Bailey, you went to like 4,000 feet, right?
Yeah, I was playing around with different motors and just trying to make sure that the stability was constant throughout, regardless of each. And I ended up hitting it. So I was pretty happy with that.
It's awesome.
Bailey, do you have an open rocket design?
Yeah. Do you want me to share my screen?
That'd
If
be,
you could, that'd be really
I'd
cool.
love to see it.
Okay. So overall, I also have the altimeter over in the nose cone. A lot of the parachute system is similar. And then mainly I was having to work with the fins a lot because I was trying to make sure that the motor stability was constant. And so it barely fits parameters, but it does. So
I see that you have 4 setting rings, which is
Mm.
very interesting. Very well, interesting. Yeah.
Robust.
Yeah, robust. How are you gonna epoxy the setting rings, or are you gonna make them modular?
right now I'm thinking of epoxying them. If you think that there would be a better way to go about that, I'm open to suggestions.
What is your method on epoxying the 2 middle setting rings?
Middle settings probably to the outside or like the interior or whatever in front. That would be where I'm kind of struggling at the moment because
I remember me, Goose, and some people currently are struggling with that right now.
yeah,
He's struggling to epoxy just the deep, because I used a rod. He's using a rod, but it's kind of a struggle. You have to be really particular with where your epoxy is on the tip, and then where the tip is crevicing with the edges of the setting ring.
right.
How the setting ring is with the wall of the airframe. You got to make sure the epoxy goes in the crevice between the outer ring, and the airframe. So there's a connection there.
Gee,
Um,
I think I have an idea.
what's yeah?
So this, I mean, so if you can imagine when you're assembling the rocket, you're going to start by the way I've started in the past is you get the centering rings and like epoxy them to your motor tube.
Mhm.
Yeah.
Then you have like kind of like this barrel looking thing that has like a whole bunch of rings on it. And then you shove it into your rocket and like you put like epoxy on the inside before you shove it in and you just hope for the best.
That's right.
That's generally the case. But what I'm thinking is you can put some epoxy on the inside of the rocket and then slide the first ring in.
Mhm.
Like everything's already like glued together, the motor tube and the centering rings.
Right.
You put the first ring in, and so like the second ring is kind of just hanging out of the rocket a little bit. And through the fin slots, because there's gonna be slots for the fins are gonna go, you add more epoxy and just like droop it in there. And then like
Okay.
you fold it around while it's still like really wet. So it coats the inside and you like push it in a little bit further. And then you like droop some more in, and then you do that, and then all 4 center rings are wet with glue.
That would work.
Yeah.
I really like the idea.
I actually got a question about that. Or sorry.
What's
Oh,
up?
no.
Good.
What's up?
I was just gonna say, so with methods like that, whenever you're, I guess, applying it before actually pushing it in, the motor tube with the centering rings, should we be worried at all about how much epoxy we lose just to like the
This when
I
sliding.
guess the sliding motion? Yeah, because I guess a lot of that would be pushed onto the interior walls. I just don't know how much we would lose. And obviously you guys have had experience with this. I just didn't know if that was an issue or not.
I honestly can't say. I don't know.
We did this.
We did
yeah,
this, and all I did was I got like one of those skewer sticks, like the bamboo things for like kebabs and stuff.
Yeah.
And I would scoop up some epoxy from the thing, and I just like droop it as far in as I could get until I had like a nice ring all the way around. It wasn't pretty,
Mhm.
but it was what it was. And then it was far enough into where like it wouldn't be sliding like too far. But I
Okay.
have no idea how to tell you the quality of the bond that it made.
You're gonna
Yeah.
have to, well, the most important thing is to epoxy this. So here's how I'd go about it. You, you're not gonna make this module, it's gonna be epoxied, obviously. So first you have the motor tube, and you have 4 centering rings, and we're gonna make sure they're placed as they are on the open rocket design. And you're gonna epoxy each one. You're gonna epoxy the inner ring to the tube, respectively with the positions. Cure that, make sure that's secure, make sure it does not slide up and down, make sure it's basically epoxied to the tube. And then once
Yeah.
it's going to insert it into the airframe itself, the question there is like, we don't, well, not the question. The concern is we don't want that tube to go up and down. We need it to stay secure. So the thing there is, do we need to epoxy the 3 upper centering rings relative to the nose cone? Like, not quite. All we need is that the bottom centering ring is the retaining the motor tube from going upwards. So basically, like in Brandon's design, the bottom centering ring is the same diameter or a bit bigger than the airframe diameter. So it holds everything because it's epoxied. There, that takes away the struggle of epoxying the outer circle of the centering from inside the tube. You don't have to
Mhm.
do the rod thing. You just, everything holding the motor is the bottom centering ring. And you don't have to worry about the tube going up and down because, well, the bottom centering ring is epoxy to the tube already, and it's gonna be fine like that.
Okay, yeah. So you're saying that we can put a little extra love and effort into that bottom one, and it should kind of hold the rest, is what you're saying.
Yeah, you use.
Okay.
I would use JB Weld steel epoxy for
Mhm.
the bottom centering at least. I would do it for all of it because I like that extra safety factor. But you can use 5-minute epoxy. I don't know about 5-minute, but well,
Yeah.
5-minute for the inner centering rings and JB Weld for the bottom centering ring. That's all right actually.
Okay.
JB Weld steel epoxy is 5,000 or 4,080 psi,
It's a lot.
which is a lot.
I don't think you're gonna be breaking any epoxy anytime soon. But yeah, another thing I noticed about your rocket, Bailey, is your rocket. If you want to get your L1 certificate and everything, like you can launch it, that's fine. But if you want to get the certificate, your rocket has to survive. So it has to go up, release the parachute, and live, right? So if your rocket's coming down, it looks like it's pretty light. It's just like a kilogram. But if it were to land on one of the fins, right, they are sticking backwards. They're gonna take the brunt of the hit.
Okay. So I should probably redesign them with less of that backwards.
Yeah. Well, you can keep the backwards as long as you can move them forward, but keep the backwards swoop so they're not like in front of the motor, but I guess technically behind the motor. Or something Randy told me is that you can have, or something I've been playing around with Zenith, is you can have like the swoop back, but just have it not swoop as back as the motor. So the motor tube, like Brandon's design, can be further back. It doesn't have to be like all the way into the like flush with the bottom.
Okay.
The question, not the question, what you need to be careful with is the design relative to the center of pressure. Just make sure that obviously the margin or the stability margin is where it needs to be relative to where your fins are placed, because the fin really affects the center of pressure. So you make sure that it's all right.
Other than that, I think your design looks killer. I mean, the fact that it's gonna go to like 3 times the height of anybody else,
Fingers crossed. Fingers crossed.
that's
and with the same motor, right? Or when
Yeah.
I open it with the J, or did I open it?
Yeah, it's with the J.
currently with the J motor.
Yeah,
you-
but I don't know meters to feet. I'm not a human.
Oh, here, wait, let me
Um,
add that.
It's like, yeah, 3.2 or something, right?
3.28 times 1,504.
It looks like almost 5,000 feet with the J.
Holy, 4,923 feet. About.
I
That's-
tried to default it to Imperial. It's not going there at the moment. Let me
You
try
have to restart the
You'll have
tab.
to,
Oh, okay, okay.
Is,
That's-
is the J motor for L1?
No,
No,
J motor
SL2.
to launch on a J motor, at least your L1
Yeah.
already completed.
What was your L1 motor?
Here, wait 1 second. I like trying to restart the application. Hopefully this time in Imperial. There. Fingers crossed this works this time. Or not.
Oh,
Rainbow Wheel of Death.
yeah, 4,936.
And then with the other one, a little bit less. Hopeless.
So that motor tube is going to be with that motor.
Potentially. I'm just playing around with motors for right now. I'm currently looking at the H motor, but I could also go with the J.
Yeah.
Has
Right.
Randy decided which one he was getting?
So you guys can't launch a J motor.
Yeah.
And
So then that would be for L2.
Yes.
Yeah.
Okay.
The L1s give you access to H and I motors. The J, K, and L motors are L2. M, N, and O are L3. So-
That would be
So the question was, how does the motor retainer work if it's like smaller than the motor tube? And Randy's suggestion was use a really small H motor just so they can get their cert and be done with it. And then, or like, but using the really small one, obviously it's smaller diameter than the motor tube, but you can use an adapter. So it's like, it essentially slides over the motor and makes it the 38 millimeter diameter to fit the motor tube. Do you have any questions?
Nope.
Dave?
I think that pretty much covers it.
Does anybody else have questions for Dave?
Brandon and Bailey. Did y'all design this together? Because it's very similar.
Pretty similar. I looked at what Brandon was doing and I was kind of like, okay, I see the logic there. And so I took certain things and then other things I was like, let me see if I want to like what I can do with thin design to see if I can reach a little bit higher apogee and work with the velocity a bit. And so based on that, then I modified and everything.
Cool.
That's really cool. Does anybody else have designs they want to show?
The design I have right now is actually very similar because Open Rocket, my first experience with Open Rocket is basically just Randy stuff, right? And when I watched Gustavo do some stuff on his thing. So basically what I have right now is very similar to what Randy has. So my question is, what else do I do to proceed with this design, right? I can share my screen, but it's exactly what Randy had. So what would I be doing now? Like, what are the things I have to be watching out for when I'm running these simulations? Things I should be looking to tweak to improve the rocket? And like, what would make a good L1 rocket? Like, how high does it need to go? And stuff like that.
I'd say at least 100 feet and no more than 3.
100 feet. Okay. I think I got that one in the bag.
Don't go too much past like 3,000 or don't pass 3,000.
Because it's really light.
Yeah. So what
Okay.
happened to me is I made my rocket and I made it with a kit, so it should have been fine. But
Mhm.
what happens is L1s typically are really light because it's just like cardboard, wood, and like a decent parachute.
Mhm.
And so mine went to like 2,500, 2,600 feet, which is pretty up there for rockets. And what ended up happening was it went up and the parachute released. Everything was going perfectly. It was a beautiful day. I was just watching my rocket like do all of its cool stuff. And then it just stayed there. Like the parachute was like too good. And so it just like wasn't coming down. And then the wind started to pick up and it just started to drift away. And then I was just like a little kid at Disney who just let go of their balloon. Single tear down the side of my face. But yeah, don't do that. Don't make it go too high because then the wind will just like take it off into nowhere. I only ended up getting my rocket back 3 months later after the dude who like there's a ranch or like a farm like across the creek from the airport. He ended up running over, I think, with a lawnmower because it was just all like messed up. But
This was us that day. We all had our one kids.
yeah, the exact same kit, by the way, just high tech.
Nice.
That's Eric. He's
Yeah.
not with us anymore. He's in Chaplet.
You said that like he passed away.
No. Okay.
Yeah.
No, yeah.
Yeah, his rocket went too far and then he just instantly died.
No, his Eric's rocket actually it ejected the black powder charge, but like way before apogee, and it just exploded the fins. And
Oh no.
rocket just as I don't know if you can see, but
It was a frag rocket. That's what it was.
yeah. Well, his rocket is a mechanical pencil. It's the big mechanical pencils. You don't see the logo, but it's there. After it came back down, well, it doesn't look like a mechanical pencil now because of the fins, but when it came back down, it became like a pencil because the fins were gone. Yeah.
You can see a little bit of like the things like supposed to be like the clip.
I can't zoom in, but yeah,
Yeah,
it's like right.
Oh, I see it. Yeah.
yeah.
The yellow logo.
Gustavo's rocket is named,
The sound of yellow.
yes. Mine is Luna. That one's mine.
Yeah. I guess the most creative part or the funnest part is like
The paint job.
yeah, it's when you can give like your final touch.
What are you guys staring at?
Huh?
What are you?
We're staying off to the Carmen line because that's where we're going.
Hell yeah. We're just trying to look cool.
Yeah, it's an artsy pick. But Donald, go ahead and pull up Randy's thing, and then we'll talk about different things you can switch around.
Yeah, I'm turning on my computer right now on my iPad.
All good. In the meantime, I guess I'll share my screen.
Yeah, go ahead.
So, am I sharing? Can everybody see?
Yeah.
Please.
What? I haven't checked really.
Okay, how do I do this? I forgot. Users. Can you go to me? Okay, hold on. This might take a while. I don't remember where it's saved. Okay.
High key want the semester to start.
See, it should be one of these. No.
Really? Well, I don't hate things. I always respect things. for what they are. But it can,
That sounds like some really unnecessary philosophy.
you would say that. No, but I get you.
You sound like you're really trying too hard, but I don't think you sound like an edgy white girl who doesn't want to like hurt one's feelings.
No, I mean, I'm for real. I'm not. We're like trying to be anything. But I get you though. It can be a bit
thing. Okay, yeah, this might take a while. Don, you can go ahead.
I don't want to do anything on.
Yeah. Let me join my computer real quick.
So can you actually make it the Saturday? If it's just,
Like I said, whatever you do.
if it's just the three of us, would you want to carpool?
Lynn's never been there before, so I wouldn't want to.
Oh, yeah. If y'all, for the people in this call, if y'all are interested, I know it's a bit late notice, but Lynn from Structures is launching her rocket this Saturday, up north and close to College Station. It's 2 hours, a 2-hour drive, but there will be carpooling. And it's like a trip that we do usually for our peeps that launch, and we just go, support and see the rockets go launch, specifically hers, and then there'd be other launches, and in between we'd go to Buc-ee's, because that's like a tradition. We always go to Buc-ee's before a rocket launch. But I was thinking we could go to A&M, but I don't know if that's too much. Go to A&M after the rocket.
Like campus?
Yeah.
I got nothing to do.
What time would it be at?
The
I expect you up at 6 a.m. sharp.
Yeah, they start at 8, but they usually start to wrap up around 4 or 5.
PM.
Okay, because I believe I work on that day. Let me check. But
We're gonna set up logistics. I'm gonna set up logistics after this meeting, like an interest form and like carpooling and stuff.
Yeah. But Donald, to change up your rocket, there's a lot of things you can change. This is like if you buy a kit anywhere, it's generally going to be this little setup. You have a nose cone that has like a shoulder is what it's called, that sticks into the airframe, and then that section of airframe has a coupler inside of it that extends into both sections of airframe, and it's connected to a longer section of airframe that has the motor tube and some centering rings inside. There's a couple things you can change. So the length of each section, you can do different things with those lengths. So for example, let's say you want to take an umbrella to like use it as your parachute for whatever reason. You want to Mary Poppins your rocket. You can make the upper section really, really long so you can fit that umbrella into the rocket. I don't know why you would do that, but technically you could. And then I guess right now it's a little abstract because you're not designing for anything other than like making sure it hits a stability and it has like a diameter. But once you start like trying to optimize your rocket for different things, first of all, you got to choose what's the purpose of your rocket. So like I said, maybe you want to Mary Poppins your rocket and just put an umbrella in there. Or let's say you want to have a GoPro. So now that you know what you want to have in your rocket, then you start deciding, okay, so now I have everything and I can start deciding where I want to put it in terms of like where the weight distribution is. If you have your GoPro like in the nose cone, obviously, there's going to be a whole bunch of weight there. Otherwise, then you can start like moving on to where everything is, like all the links and stuff. So your nose cone, if you want to get really technical about it, you can play around. If you go up to flight simulations on the top, at the very top up there's flight simulations. You see where it says body tube? Yeah, there you go. You got it. And then click any of them. And then do run simulation. Yeah, and then simulate and plot. Okay, cool. And then when you export the data, right, you're gonna get a whole bunch of data. if you want to get really technical, you can play around with like nose cone shapes to reduce the amount of drag that you get. The easier way to do that is just play around with it until your apogee gets highest. But sometimes it can be a little weirder than that. So you can start playing around with like the actual data that OpenRocket comes out to.
I was muted this whole time. So I was asking this question, what exactly am I trying to optimize in this rocket, right? You already said it has to reach at least 100 feet. Obviously, I'm gonna aim for more than that, but
Yeah.
what will make
So-
my rocket a good rocket? Like, what am I aiming for?
Yeah.
For an L1?
So whenever you're optimizing, obviously you want to optimize to a target. That can be anything really. In this case, like I said, it is weird because there's no target that you guys have. It's pretty much free reign and just like be creative with it. But let's say like you want to go to exactly 2,000 feet, exactly, like not 1 inch more, not 1 inch less. You could call that your target apogee.
Okay.
And then you can start optimizing to that. So let's say, your stability is at a 1.6, but you can keep the same stability, make your fins thicker. So instead of maybe like 1/8 of an inch, make them 1/4 inch thick. And then that'll tank your apogee from like 2,600 to like 2,100. And then you can make your nose cone a little stubbier. And so that's like, kills a little bit of your height as well. And you get closer to like 2,060. And then, I don't know, you can play around with a lot of things.
Yeah. Yeah. Okay. But what am I trying to add? Okay. So, what was the criteria for an L1? Just to freshen things up.
So the main criteria for an L1 is to have a rocket that you built yourself. So it's not like somebody built it and then you stick in a motor in it and then call it yours. Like you
Okay.
have to build it. You have to know certain things about it. It's not technically a requirement, but Randy will ask you things about your rocket to make sure that you built it. So like, what kind of epoxy did you use? What is the shear stress, or what is like the tensile strength of the epoxy? They seem like oddball questions, but they aren't that bad. Once you start working with it, it'll stick in your brain just from having worked with it.
He'll definitely ask you where's the center of pressure relative to the nose cone.
When you launch a rocket, you need to know the center of pressure and the center of gravity. They do need to be marked on your rocket. So you see how it's like a cross? It's like
Yeah, these two dots, right?
a checkerboard with a circle checkerboard and then like a circle,
Yeah.
a circle inside of it. You gotta draw those on your rocket. They don't have to be like blue and red. You can just get a Sharpie and then make those symbols where the center of pressure is and center of gravity.
Okay. Also, you mentioned something about you were like, what you have to figure out what the purpose of my rocket is. Like, if I want to stick in a GoPro or something.
Yeah.
So that's just like extracurricular thing I can do to my rocket, right? It's not a necessity to get a
It's not a
certification.
necessity to get your L1. The basic criteria are like I mentioned, you have to have built it yourself. You have to launch it successfully, so it just goes up and there's not like an explosion or anything. Once it hits apogee, it releases a parachute. It does not have to be an electronic recovery. It can just be like the little black powder charge on the top of the motor. The parachute has to release. Well, it doesn't have to release, but essentially you have like your ejection work at apogee. And then when it comes back down and it hits the ground, there's no excessive damage. So obviously like the paint scratch, that's damage, but like you could technically still fly it. That's what they're looking for.
Okay. Is anyone else like currently doing something extra to the rocket? The L1 rocket?
I know Brandon was playing around with adding like that centering ring so he could keep the parachute towards the top. That's not technically necessary. You can just shove the parachute into the open space inside and call it a day. But yeah. Also, Randy spoke about people making their 3D printed nose cones. So you can play around with nose cones as well. And if something like you come up with like, let's say an LV hack nose cone, right? So that's one of the nose cone options in like OpenRocket. That's kind of hard to there's like a mathematical formula on how like that geometry comes out. You're not going to go to the trouble of like CADing that and then make like 3D printing it. That's a little, I wouldn't go through the trouble of that. So just choose something. It could be anything. You just go on like AutoCAD or SolidWorks, come up with a random like cone shape, post a cone shape idea, and then 3D print it. So that's something you could do that's like extracurricular, if you want to call it that.
Okay. Something else. Okay, I looked at everyone knows the showed their rockets, right? They were showing their L2 rockets, right? Because they had some things on there I don't have in my rocket. And also the second question, is this everything I need in an L1 rocket, the design I have right now?
Yes, you have a nose cone, you
Okay.
have an airframe. You don't technically need a coupler. It's just there. You have a parachute and shock cord to hold the parachute, together with the sections of the rocket. You have a motor and some fins. You got everything. Technically, you don't need centering rings. If you find a way to do it without centering rings, that's fair game. It's not a requirement to have centering rings. You don't need a motor tube. Those things are just very, very common. It's like the simplest solution, but you don't technically need that stuff. As long as a rocket can go, okay, here's something really funny. There's people who will strap motors to Christmas trees and launch those as a rocket. And it works. I mean, like, it's valid because, well, as long as you can prove, it's a safe design and it's going to go up and not like explode. That's mainly what they're looking at. In this case, you want to do your L1. You just want to stay safe and, make sure you get your L1 and you can start playing around with other ideas. But there's no huge constraint other than it goes up, it must have a parachute, and it must land safely. And you have to have made it yourself for the certification. You can launch whatever you want after you.
And every part of this rocket, I can commercially get it.
Yes, there's nothing against commercially buying. Like I bought a kit, all the parts came. All I had to do was basically glue them together. That's fair game too, as long as I'm the one who put everything together.
Okay. And with the apogee of this rocket, right? This is good enough to pass. I want to make some other changes to it, like just so it's not exactly what Randy has, but is anything wrong with this design right now?
Nope, nothing wrong. It looks great. I
Okay.
mean, there's obviously things that you could change about it, and then that I would change if it was my rocket. But those are just, personal changes. This, if everything's glued together and it doesn't fall apart, this looks like a good rocket.
Awesome. Thanks.
Yeah. So I'm still continuing to look for my rocket.
And as far as the materials that we will use, like the specific nose cone and like the finesse ratio for all of that, when will we, I guess, decide, what specific materials we'll be using?
Let's see. We can decide that today. It's really not too big of a deal. Y'all can decide, for example, fiberglass for the fins, but I mean that's more expensive and there's no reason to go that. But I mean, I'd suggest wood for the fins, wood for the centering rings. There's commercially available like cardboard motor tubes, and everything else is cardboard. You can 3D print the nose cone. I'm just throwing things out there, but y'all can just come to the conclusion of whatever you want.
Yeah, because the main thing that I was kind of worried about was the nose cone, just because obviously you can mess around with the finesse ratio and just all of that, but obviously once you increase that ratio, you'd have a lot more surface area up near the nose cone, so that would bring up your center of pressure and all that. So
Yeah,
I just wasn't exactly sure how that was gonna go about.
Is this it? This is it. Nice. I found my thing. Yeah, the nose cone can change, like the finesse ratio and all that stuff with your 3D printing. But
Mhm.
I'm inclined to say for an L1, as long as it fits inside the printer that you're trying to print out of, you should be good.
Okay.
Okay, I'm gonna share my screen. So y'all can see. So this is my L2. I've changed a little bit since the one I shared before that you guys maybe looked at on the channel or whatever. My rocket, honestly, I'm just going for cool factor. Like that's my design criteria. There's nothing that's like I'm trying to achieve particularly. It's just, trying to make something that looks cool. So I made a rocket. Oh, also I wanted to be at least as tall as me. I don't think that's quite the case with this one. I think it's a few inches short, but like I can add it somewhere. But the whole idea is I chose that's JP's L2 behind me. Maybe you guys saw that. But anyways, the nose cone, I chose 16. So I have a 4-inch diameter rocket. So I used a 4:1 ratio because that's just kind of what I've heard. Rule of thumb. It's nothing like specific you have to adhere to, but it's what I chose. And it looks cool. And then I added canards because another thing that I wanted to stick to is having my fins be at least 1 body caliber in length. So like from the surface of the rocket to the tip, it's at least the diameter of the rocket. So here, I think these fins are like 4 point something, maybe 5 inches. Their height is 5 inches. Yeah, so it's a little bit more than length. And once I did that and had them like a reasonable size, it made my stability way too high. And I didn't want that. I didn't want my rocket just going off into the distance. So I added some canards. They're not very common, but there's nothing like against them. You can add canards whenever you want. And so to make sure the canards are like not flap around and like break in the wind, and they're like sturdily connected, I have this this centering ring highlighted in red, like the thicker red right here. And it's basically just gonna be a little thing that is that wide, just so you can like stick the fins together, I guess. And then there's a main parachute here that has a shock cord that connects right here to the top of this bay. Shock cord connects up to the tip. There's another drogue parachute in here, just so that well, yeah, because I don't want my rocket to fly off like last time. So I'm gonna have a small parachute that basically just controls its descent down to like 1,000 feet or less. And then once that's done, then it deploys the main parachute. Then it touches down softly. And then I'm planning to get my L2 with the J240, which is pretty small. Not much going on. But just to get the certification. And that gives me an apogee of, yeah, 2,700 feet. So nothing special. It's just going up there and coming back down. Then there's these other motors that are really expensive. They're like $800 or whatever that you can get in L2. And what's really cool about them is that they burn slow. So I'm not like burning really fast and just making my rocket go like off into the distance, like at Mach 3 or whatever. I can just coast just below Mach 1 and not have a whole lot of drag. So for example, like this K820. So it's really long. I should probably extend my motor tube. My stability is, it's kind of low. I honestly, if I'm gonna launch it, I'm just gonna, call it whatever, call that good enough. And I go to 8,000 feet with the L2 motor. So that's basically going to like Oberon heights with half the motor, which is cool. But I mean, that's really my design criteria. Also have avionics bay right here. Another cool consideration was like if people on the team want to test electronics or like test different things, like I have more than plenty of space in here because I'm just gonna use like one little computer chip. It's like 1 inch by 1 inch to control my separation, and then all the rest of that space in there is gonna be free space for anybody who wants to test stuff on the team. But yeah, that's my rocket.
And did you say those upper fins are called canards?
Yes. So the fins in the back are just, I guess, called fins. These ones, I could call them front fins or something, but I think I don't know for sure, but I'm fairly certain that the front fins are called canards.
Okay.
I really like those front fence. What did you say they did again?
So let's go ahead. I'm gonna get these and I'm gonna make them height of 0 inches. So they're basically not there. Now my stability is at 2.74. So if I undo that. If I undo it, I'm at 1.4, which is, teetering below what's a safe range of like 1.5. But so I'm okay with a 1.4. I'm not too worried about that. But the fins help me do that because if my center pressure is too far behind my center of mass, then that makes my stability really big. This just pushes it forward.
Gotcha. Also, I know you failed the whole testing thing if any of your fins break, right? Does that apply to the top fins as well?
Yes. Also, I think for like L3s, Randy, I've heard in the past can be like really anal. I mean, L3s is a while away from now, but he'll like stand on the fins, just make sure they don't break.
What happens if he actually like destroys your rocket? Does he just say sorry before
Yeah,
he even launches?
sorry, but like good thing he didn't launch because
shit.
if that thing breaks while it's like a mile up in the sky, and it falls down on somebody's car, that's bad news. So how are the vibes? Y'all feeling excited about your L1 launch?
Good vibes.
Yeah.
Good vibes, you know.
Yeah, I'm excited for it. It's gonna be fun.
I'm excited too. I ordered my stuff, it wasn't fun because it hurt my bank account, but
Yeah.
it's still not here. I ordered it on the 20th and it was supposed to come in 5 days. And I think because of like Christmas and stuff, they misplaced it because it's been like 15 days. And they
Oh
haven't-
no.
Is it gonna come as a one package or like several parts?
I only ordered the airframe stuff. So I only ordered the upper airframe, the coupler that goes in between the two sections, and the lower airframe.
How did you paint your L1 rocket? Did you just get some spray paint or?
Yeah, just spray paint.
Okay. You can have anything on it, right?
What's that?
You can have anything on it.
I mean, as long as it's not like hentai or something. Like it has to be like, normal stuff. You can put flames or like, I don't know,
Okay.
parakeets.
Well,
Just
specifically, why can't it be hentai? It's my rocket.
Well,
Question.
yeah, I'm fairly certain there's a clause that says you can't have like obscene stuff on your rocket.
Okay.
So that is another rule.
Like a possible rocket.
Yeah.
Just
That-
destroyed
that
my
would not
plans
be
and
a-
stuff.
Huh?
So they just destroyed my plans.
Oh, good. I wouldn't represent you. All right. Well, any last questions? Straggling questions?
Yeah, can you remind me of the timeline for Saturday? Because I actually work at 5:30. So
Yeah.
I don't know if
So, yeah, they start at 8 a.m. and they start wrapping up at 5 o'clock, but you honestly, you could leave whenever. It's not like you sign up and you have to stay there. It's just
Okay.
like, it's an airport. You just show up, launch a rocket, and if you want, you can be out there by 10, like out of there by 10.
All right, cool. Yeah, because I think it would be interesting to go see just how that functions, you know? So,
I would definitely say make sure you know how far it is from where you are. Cause just 'cause
Yeah.
like 2 hours for some of us, maybe 3 hours for you, so.
I'm sure.
you said it's a College Station, right?
Yeah,
It's like 30 minutes past College Station.
Just
All right, because I think I'm closer to College Station than UH is.
Yeah, I'm a little further north. I'm in the Woodlands, so it ends up being like an hour and a half drive. It's not
Yeah,
bad.
I actually live in Magnolia, so
Yeah, you're good.
cool. Okay, well, I'll probably see you guys there then.
Well, thank you so much, guys. We'll wait for JP to drop the address. There you go, Hearn Municipal Airport in
Awesome.
Freenan Lane, Hearn, Texas, 77359, United States. Hearn, Texas.
Thank you very much.
Awesome. I'll catch you guys later.
Yeah.